Good morning and good afternoon, depending on where you are in the world. It is a pleasure to invite you to this co-hosted webinar, Atoms and Algorithms: A View from the Regulator. I'm Cindy Vestergaard, Senior Fellow and Director of the Converging Technology and Global Security Program, and my co-host, Sarah Case-Lackner from the Vienna Center for Disarmament and Non-Proliferation. Sarah, maybe you want to say just a quick hello.
Hello, I'm Sarah Case-Lackner, as promised, from the Vienna Center for Disarmament and Non-Proliferation, and I lead our efforts on emerging technologies at VCDNP.
And obviously, this is a topic that is very topical and something that even in terms of is moving forward, obviously, at the regulator level. And we're here very much to thank our three regulators from Canada, the United Kingdom, and the United States. And I have the pleasure to also introduce Gretchen Stewart, who is actually going to start us off with opening remarks. Gretchen is the principal engineer, chief data scientist at the Intel Corporation. And Gretchen, over to you to tell us first about what is AI? What is this technology all about?
All right. Well, I'm going to bring up some slides as I'm talking first. Thank you so much. I'm delighted to be part of this. And as you said, good morning, good afternoon, good evening, kind of depending on what time of day you're at. I need to, change a display. So give me just a second and I will do that. It's bouncing between multiple screens here in my office. So
no problem. While you're doing that, Gretchen, I'll just remind our audience that's watching to, if you have any questions, please put them into the Q&A. If you put them into the chat, we might not see them. So please put any questions into the Q&A and we'll get to those later.
Yes. So again, thank you so much. I'm really glad to be part of this. Please know I'm not going to give you an Intel marketing pitch. I just wanted to highlight some of the things that are going on. And the truth is, even already today, OpenAI released their mini 03 ChatGPT, mini algorithm from a generative AI perspective. So the world is moving pretty fast. And I just wanted to highlight that by the end of this century, by the end of 2030, there's going to be 40 billion things that are connected. And the truth is, I think a lot of people really do get nervous about what is AI. And the definition of it is that it's continually evolving, I have to tell you, because let's go into I'll call it the Wayback Machine. In 1956 was when the first conference about artificial intelligence and machine learning was put together. It was at Dartmouth College. It was the precursor of the NSF here in the US, but it's definitely been part of what's been evolving and allows people to take lots of data and get better answers. But the reason I'm just highlighting 40 billion is think about what that means from a connected perspective. And think about how much, you used to have floppy disks and lots of other things that people use way back. But you're able to carry, in my phone, what I originally started when I was in, high school, playing around with systems.
So Gretchen, when you think, we can't see your slides.
Oh, you can't?
No.
Oh, all right.
Sorry for the interruption, but I know the
No, thank you. No, I thought I was sharing. No worries. Let me do this one more time. And I will. All right. User error. Sorry about that. Pilot error, as they call it.
There we go. It's coming up now.
All right. Perfect. And then I will have to do the one change, I believe.
Yes.
One more time. Can you all see that?
It's coming up. It's not the full screen though.
Okay. Hold on. Yes, because I have to change the display. Now it should be. There we go. All right. Good. So as I was saying, think about all of the connected systems that are out there. So I pulled this up honestly this morning when I said, okay, give me a visual of what you think about when you think about artificial intelligence. And you think about machines, you think about your environment, you think about how it can do predictions. Some people think the cyborgs are going to come and take all your jobs. I mean, there's all these things that people are thinking about. But what you need to, again, think about is in that Wayback Machine in 1956 is when that first conference was. So really what a lot of this is trying to take data and get better answers from that data. And I hate to be simplistic, but it really is that. It's about analytic techniques. So AI is solving problems as opposed to AI is the answer or the answer to the question. It's really about mimicking cognitive functions associated with the human mind. But think about it, there are lots of different approaches. Again, autonomous, it does decision making, predictive analytics. So when you want to look at what is AI, let's really think about the fact that there's a lot of definitions and there's a lot of things that people, I think, confuse. They talk about artificial intelligence, and as I said, try to mimic machines mimicking human, but then a subset of that is machine learning. And when we think about machine learning, that's finding patterns in the data, that's object detection, that's recommender engines, that's looking for predictive maintenance, analytics in data around fraud detection, things like that. And then there's a subset of that around neural nets. So think very, very large math equations, very, very large matrices, 20 by 48 by 20 by 48, not something you could do by hand. And then a subset of that is deeper learning. And then generative AI is the thing that you hear about every single day. But it really is a subset of the potential techniques that you really can use to get answers. And so I know a lot of people, again, you think about it as, things do definitely go wrong. I just have some examples. People probably remember a number of years ago when Microsoft first came out with their AI chatbot and what a mess that was, and it crashed. And issues around the autonomous vehicles for Tesla. I'm not highlighting this to say that everything's bad, but just to say part of what this conversation is going to be about, and part of what's happening right now is NIST, as an example, has a safety institute. So really thinking about how you can ensure that you are looking at the responsibility, the ethics, the safety of what you're trying to get an answer from all of that data. And again, this shows some things that are going wrong, but it also shows that organizations like ML Commons, again, is also looking at how you form and what you need to think about from a responsibility and ethics perspective. And the next slide, I want to highlight this only because I think, and Cindy and team were fabulous to send me, and I have it in front of me, so I want to make sure I have the name correct. But considerations for developing artificial intelligence systems in nuclear applications. I think that's a really great place to start. I think it talks about the fact that really what you need to do is define the challenge. AI might not be the answer. Generative AI absolutely might not be the answer. It might just be you're trying to do something around network automation. So the idea is really think about what is it that you're trying to do? What is that approach? Who are the people that you need? One of the things that I always say is AI is a team sport. So it's not one single person or a single architect or an engineer or a doctor who can do all of what's needed to ensure that you're getting the right data and that you're coming up with the answers that are really accurate and very helpful. You also need to think about how are you going to build your teams to do this? So do you want to do, which most people are doing today, agile 6-week sprints? Think about how you might do that. Then you need to really figure out, do you even have all the data? Are you collecting the data that you need? Lots of times you don't have all the data that you might need. There may be public sources that you need to go to. And then think about, can you do that within the infrastructure that you have? Or do you need to leverage a cloud infrastructure? Or do you need some kind of hybrid? And then the other thing I think that's really important, which the document that the Canadian Nuclear Safety Commission, the UK Office of Nuclear Regulation, and the US Nuclear Regulatory Commission put together really talks about thinking through this, but then also making sure that from an organizational perspective, that you've got all the right people involved. And again, it really is a team sport, and it's something that we all need to work on together and have people who've got the diverse perspectives and who are really able to build in all the right data to give you the best answers, especially from a safety perspective, and especially if you're dealing with national grids and other things where you want to make sure that that information is pulled together in the best way. And as from everything that's happening so quickly, all of us have rising expectations. Not only do we expect everything to be automated and at our fingertips, we also expect that there are the right regulations. We also know that we have to think about talent. So here's a quick little thing about Intel that we've done is we have over 800 hours of AI content that we put together. I won't call it curriculum because we're not teachers and we're not professors, but it's really as simple as what is AI to how do you load a Jupyter notebook? How might you do predictive analytics? What's the difference between a KNN model versus a forest model? What might you be looking at to do maybe a naive Bayes? So it really goes through the gamut, and it's something that we all need to think about because as we move forward, we all need to be really data savvy. And it's really critical to ensure that not only the current systems that you have, but that you really try and figure out how to build it on rather than, and build it into the process rather than bolt it on. So the idea is really look at what you have today, pull that team together, and ensure, as I said, that it is the team sport, that you've got all of the people that you need to be part of the discussion, that you understand where the data is, that you think about your governance models. And again, the stuff that everybody on this panel has put together is an awesome place to start. And I believe that was done in maybe September or October of last year. So still really timely. But the truth is things are changing every single day, every hour. And sometimes it does feel a little like the Wild Wild West. And I do have to say to you, even as an engineer and a data scientist, I always feel behind. So do not think anything other than that because it is moving so quickly. And with that, I'm just going to say thank you for letting me give you kind of a stage setting. I probably gave way too much information, but I think it's a great place to start from the conversation so that we can ensure that we think about who's part of the governance, what are those policies, what's the regulation, how are you responsible, are you thinking about the ethics, where is all the data, who's part of your team. I mean, there's a lot to do, and it's not a simple process, and it definitely is something that, as I said, you need a team of people, and you need to really ensure that you are looking at all parts of your business and all parts of your operations, that you've got all the right people involved to really think through how you're going to make the difference to automate some things and to provide better answers and improve, working conditions and ensure that you, as I said, have the best answers that you can for the problems that you're trying to solve. And with that, I'm going to stop sharing.
Thank you, Gretchen. A couple of follow-up questions for you.
Sure.
I mean, I've got a lot, but I'll pick just a couple here. So the first one is, in the nuclear sector, I mean, we used to joke that given the demands of AI and its energy demands, that we would need nuclear reactors to power them. And here we are, actually, where that is we've seen a lot of agreements over the past year, looking, what all the big tech are looking at, advanced reactors, small modular reactors, even connecting to big reactors on the grid, which of course is leading to a big debate in a variety of different ways. But one of the things on AI, and what we always find with technology is that as it advances, it also becomes more efficient. I'm wondering if you can take us through a little bit more about what you can say about forecasting in terms of energy, and also what we're seeing in the technology. I mean, DeepSeek was last week, and kind of take us through a little bit about what we're seeing in terms of the AI and its demands.
Yeah, no, thank you very much. And I honestly am delighted to work for a company like Intel where that really is part of our design center. Because the truth is, if you start to look at especially these very, very large language models, there's 5 or 6 companies in the entire globe that can really afford to build those data centers to go through that level of information to be able to get the training and the inference that you're talking about. And those systems are huge in terms of the energy usage. And they are because you need not only a CPU, you need in some cases, each CPU needs 4 or 8 or 16 GPUs. And those GPUs right now, when when I started in the high performance computing space, which honestly is where a lot of AI was done for years around computational fluid dynamics, et cetera, those GPUs initially might have been 100, 200 watts, and now they're 1,000, 1,200. And when you start adding those up, the truth is, as I say to people, and I really don't want to say it, is we're going to melt the planet. And so part of what we're really looking at, and part of what I'm starting to see more people do, is how can we tokenize in a better way? How can we ensure that we're using the memory most efficiently, but when we don't need memory, that we turn it off? How can you also look at, as an example, we're building and looking at neuromorphic processing. So not only predictive, but moving towards self-learning. And in that case, we have done some tests already in comparison to current GPUs and this accelerator that we're working on. Our accelerator is using sub 10 watts of energy as opposed to multiple thousands of watts. But it's a completely different design. So we really have to think about, are the computers of the future the von Neumann 1945, 1948 kind of thought process, memory, CPU, or do we really need to think about what's a different architecture design? And I know it's a long-winded answer, but I think the truth is, from a research perspective, it's really important. That's why there's a lot of AI institutes around the globe. There's a lot of people from University of Heidelberg to MIT to University of Australia that are all working together to look at how can we not only build software that uses better, that is more energy efficient, but also how do we build hardware that's energy efficient? Because in the end, it's not a hardware or a software problem, it's both. Hardware needs software and software needs hardware. And so how do we do a better job at that? And also, how do we leverage clouds in a better way to be more efficient? So I think all of it is, where we need to get to. Are we there yet? Absolutely not. Because truthfully, there are a number of companies who are in that fat, dumb, and happy kind of way that they've been for a long time. And hey, we'll just create more TDP. It doesn't matter if the thermodynamics goes up. Yeah, it's okay. We'll just keep doing it. And so I think people are beginning to realize that you need less. And DeepSeek's a great example where even now some people are starting to peel back and say, well, was it exactly $500,000 that they really use? So, I mean, I would have had a different answer last week, honestly, than I do today, because it seems like maybe there was a little fudging of stuff, but, in the end, that is absolutely what needs to happen. The software needs to look at, do we have to have those very, very large language models, or does it make more sense to create smaller versions of those within your environment with your data, leveraging much less energy than you need to?
And I think that's a really good point, because when we're talking about the nuclear sector, certainly it's about building, bespoke, right, for the actual variety of different sensitivities, of course, that are in the nuclear sector, but operational as well as governance issues that are there. Just in our last minute together, I wanted to ask you something that, we've joked about this before, but I think it's important to put forward. What is AI not? What can't it do?
AI is not a human.
There we go.
AI is not a human. Although I will say the interesting thing about DeepSeek is it can do the strawberry question, which if anybody knows what that is, or I'll explain. The strawberry question is none of the other models, because they chunk the information and correlate it to the next batch of text or information. And so in the idea of strawberry, you ask how many R's are there in strawberry? None of the other models have been able to answer that, but DeepSeek can. So it is looking at not only individual letters, but the chunking of those letters from a text perspective. So it will be interesting to see how things move forward with that. And I think, I don't know if that answers your question.
No, it does. It's not a human. And I think that's actually a perfect.
Exactly. Yeah, it's not. And I don't think it will ever be. I mean, I am very excited about AI. I think I was a math major, so it's all of the math. And so the fun part about this is there were things that I could think about doing, but equations that would have taken me, years and more paper than could fit in my office to do. And now that you can use computers, you've got networking and storage and things that can do in unbelievable kind of calculations, but in the end, you still need a human in the loop. I mean, if you're the Department of Defense, you still need a human to go, is that a good guy or a goat? I mean, some of it can go through and chunk out maybe 80% of it, but you're still going to have some stuff that you're going to need to look at. And I think that that's really true for people who are in the nuclear spaces. There are definitely things that you could look at that could just make people's jobs much easier and more efficient. And then you can do all those things that have been below the line that you've never been able to do and think through, because now you can worry about not having to do some of that, silly stuff, but that you still need a human. And it will never, as I said, the cyborgs will not come down and take people's jobs. I truly believe that.
Thank you so much, Gretchen. I will turn it over to Sarah and the humans in the loop in nuclear. Over to you.
Thanks, Cindy. And thank you, Gretchen. That was a fantastic way to get us started on this conversation today and a great first half of the discussions that we're going to be having here. Going into the second half, though, we've brought together 3 excellent experts, all from different regulators. And let me give you their names and titles. You can see their names right there on your screen. But just as a reminder, we have Matt Dennis, a senior data scientist from the Office of Nuclear Regulatory Research in the U.S. Nuclear Regulatory Commission. We have Kevin Lee, the lead of Disruptive, Innovative, and Emerging Technologies in the Canadian Nuclear Safety Commission, and Andrew White, the superintending nuclear inspector and head of profession for the Electrical and Control and Instrumentation Engineering in the UK Office for Nuclear Regulation. So since we have 3 great people, I'm going to propose, and this is what we're going to do, a 3-3-3 system. And that is 3 people, 3 questions, 3 minutes per question per person. That is 3 cubed also, since we were just talking about math. And that gives us 27 minutes, which should be right under and give us still a few minutes to get to some questions from the audience before we close out. What I'd like to do in this conversation that we're starting now is to turn around a little bit. We were just talking about AI in general, thanks to Gretchen, and also about how nuclear, a little bit, could help AI by providing the energy that AI is going to so desperately need. But turning that around, how can AI help nuclear? That's where I want to go now. And so let me start. For each person, I'm going to start now with Kevin, just because he's the first one on my screen, possibly not on yours. And I want to ask, in Canada, and I'll ask this of every one of you with your country inserted in for Canada, what kinds of applications are being talked about in terms of nuclear and integrating AI into nuclear? And what are the kinds of discussions you're having with operators and with others on this topic?
Okay, thank you, Sarah, and thank you for picking on me first. In Canada, I would say one of the biggest areas we're seeing our operators talk about nuclear is in the realms of predictive maintenance. So the concept of, rather than having scheduled maintenance, you have sensors, you map it with AI, and in essence, you are able to effectively predict when you need to do maintenance rather than just scheduling maintenance. There's a fair amount of research being done around this, and it's also being paired with just-in-time supply chain management. So as you know, nuclear operators currently, under scheduled maintenance, have to keep vast stockpiles of spare parts. By having predictive maintenance, by linking that to the supply chain, there's the possibility that operators can greatly reduce the amount of inventory they need to have on site at any given time. So that's one area they're exploring. So how do we engage with industry around this? We do it through a number of different vehicles, but one that we tried actually last fall, and it was interesting in that we utilized both the US NRC and the UK ONR as well. We had what was called a regulatory reg lab, or a sandbox exercise, where we actually looked at those. We had the 3 regulators there, so those representative from the CNSC, from the UK ONR, and from the US NRC. We also had operators in the room, so 2 operators from Canada, another operator, I believe, from the States, and we had 3 service providers, so sort of the 3, 3, and 3 that you just talked about. And the idea is that it's Chatham House rules. You get together, you talk about this problem statement, i.e., what is, let's say, the challenges and the opportunities posed by predictive maintenance and utilizing that within the supply chain. All of which is to say that you spend that day together, you spend maybe 2 days together, depending on the type of issue you have, and you get to talk freely about what might be some constraints around these applications. The good news on this one is that it was the first that we've tried together, all 3, and it's nice to see that all 3 kind of look at this and kind of have a regulatory stance that is somewhat coherent between the 3. There will be a paper published on this. So there will be shortly, the EPRI, I believe, will be the publishing body as well as the IEA. So long story short is that, yes, we do get into these discussions. We are talking to industry, and industry is talking to us about what their plans are around AI. If I look back 5 years ago, everyone was keeping their cards very, very close to their chest. There's an openness now, I think, with industry willing to share with regulators. And at this point, I'll stop talking and you can pass it off to whoever's next.
Thank you, Kevin. That was really interesting to hear. I've heard, of course, a lot about predictive maintenance and how AI is going to be helpful in all sorts of contexts lately. It's also interesting to hear the Reg Lab mentioned, and I'd be interested in hearing the perspectives of both Andrew and Matt on that and its value. But first, I want to turn to Andrew and ask you the same question with the focus on how is it different in the UK? Is it similar to what's going on in Canada, or is it different?
Yeah, I think it's incredibly similar in the UK as where elsewhere where it is, actually, to be honest. So as far as I'm concerned, we see a wide range of applications. Some of those are for administrative use, for efficiency gains. Some of those are actually directly focused on safety. So actually, we're seeing some very interesting applications coming forward. For example, applications to improve safety cases, and also to use AI in a very complete way, using machine vision to detect waste, nuclear waste, and to sort it and repackage it. So some really quite significant applications where you couldn't use anything but AI to actually achieve what you're trying to achieve. So what we're trying to do in the UK as the civil nuclear regulator is to engage early with those, we call the in the UK, in the US, they're called operators. In the UK, they're called licensees. And what we're trying to do is to engage early to ensure that, first of all, we gain understanding as a regulator of what people are trying to do and what the safety issues might be with what they're trying to do, but also to actually smooth and help the process of actually getting those new systems deployed. So we believe that AI will have significant benefits to safety, and we're fairly sure that without that, there would be a drop in safety performance. So we want AI to be deployed. We want it to be done in a safe and secure way. So by having these early conversations, we can actually move people in the right direction and also skill ourselves up as well. So in the UK in 2023, we held some sandboxing activities where we considered 2 AI-related applications, and we spent some days together putting together a series of questions and answers and suggestions, which ultimately resulted in a really useful report, which identified what AI was capable of, but also its limitations. And by having those early conversations, we've reduced the risks that the developers are taking because they are not working at risk. but also by reducing the regulatory risk as well, that right at the end of the line, we are having to say no, which we really don't like doing. We want to see the innovation. We want to see the benefits that AI is preferring to us. And we want to find any way that we can do that whilst ensuring that the applications remain adequately safe and secure.
Thank you, Andrew. I think this actually, you said it was very similar, but what you brought out were a lot of actually quite different things. And what I really appreciated hearing about was about safety, and in particular, improving safety cases. I mean, we talk a lot about how AI is going to reduce safety. It's awfully nice to hear about a case where it could really improve safety. And so with that, I would like to turn to Matt and say, how is it in the US? Are things different? Are the operators more forward-leaning, less so? And how are you engaging? Does it look similar?
I think it looks quite similar. And in fact, I reflect back when we started the trilateral paper between the three organizations. We were originally going to try to document all the use cases that we were seeing in the three respective countries. And we realized, one, time would get away from us, and the evolution of things. Back when we started, NLP, natural language processing, was the big thing. Then Gen AI came on the scene, so stuff is evolving quite rapidly. And then we decided that we all kind of are seeing the same things. From our perspective in the United States, as to how the nuclear industry is using AI, I can point to our engagements that we've had with our external stakeholders. So in 2021, we started the NRC's Data Science and AI Regulatory Applications Workshop Series. It's been incredibly beneficial for us to take the pulse on where industry is using artificial intelligence. And so part of that has been getting industry to come to the NRC in a public meeting and discuss what they think, where do they think they're going to use it, how do they think that needs to involve the regulator, and just an open discussion about that. So back in September of this year, actually, right about the same time we published our trilateral paper, we had our workshop, and the Nuclear Energy Institute came and gave a presentation on a whole slew of use cases where industry is using artificial intelligence. And in fact, they presented over 30 areas where industry is either using it for work order optimization, to do preventative maintenance or corrective maintenance predictions, like Kevin mentioned. There's areas in waste processing, like Andy talked about. A lot of it is in non-regulated areas. So business process optimization, efficiency gains, potentially writing regulatory documents using generative AI. But there is a lot of future interest. And so of those 30 use cases that NEI presented at that in that presentation at the workshops, we got to see the whole gamut of stuff, and then a sort of a ranking of where they think they want to go in the future with either generative AI or potential use cases that may cross that line from a business optimization perspective into something that could be more of a safety application area. And so I think that's what the three regulators here, CNSC, ONR, and the US NRC, are all watching with extreme interest.
Yeah, Matt, that was actually really fantastic. Over 30 possible use cases. I'm sorry, but I want everyone to take that in for a moment. I've been doing this, pretty intensely for a little while, and I've heard of a lot of opportunities, a lot of use cases, but hearing that someone could just make a list of 30 just like that and present it to the NRC, that's something. And so with that, I would like to turn to Cindy, because I don't want to monopolize our three great speakers. Let Cindy have a chance to ask a question. I'm sure you have one in your mind.
I do, but I'm actually just going to give a quick two-finger to Gretchen, because she wanted to talk a little bit more about how they use predictive analysis, yield analysis, and supply chain. I think it'll be a nice complement here.
Yeah, I think, as Matt and Andrew and Kevin have brought forward, so we've been using analytics within our fab plants. So really looking at yield and leveraging artificial intelligence has gone from 97% up to very close to 100%, where really we're not having some of those same challenges that we had with the silicon not being what it needed to be, and then having to rerun the whole process. The other thing too is, as you all know, we're building multiple new fabrication plants in the United States. And so part of, I think this was maybe Kevin or Andrew mentioned, we're using computer vision. So when somebody walks on, do they have their hard hat? Do they have everything that they need to be in this particular area? Or is this somebody who should not be in this particular area? And again, really helps us from not only preventative, but it really ensures that things are moving forward faster and we're able to build the fabrication plants as quickly as possible.
And just to go forward, thank you, Gretchen. And back to our three regulators. So safety seems to be, as Sarah said, an interesting one that we usually fear instead of actually thinking that this can help us assuage our fear. But what about security and safeguards? What about the non-proliferation and the security side? I'm wondering if our regulators can talk a little bit about potential use cases there, or if that's too far away, or their thoughts on that. Kevin, actually, no, I'll do the other way around. Matt.
So I think all of the beauty of AI is it's a Swiss Army knife for a lot of applications, right? And so that's actually been a blessing and a challenge for us, because for our industry, it means it can be used in a lot of different areas. For us as a regulator, it's a challenge because that means we have to cover a lot of ground on throwing AI at a lot of different use cases. However, again, and I'll go back to our AI public workshops, those have been another area where it's been great to, one, watch the academic development of use cases. So while right now we're not seeing a lot of near-term use cases for safeguards and security for AI and nuclear, there's tons of research on the area. And I know the IAEA has several projects that are potentially ongoing with the U.S. national labs, developing some tools that might be more focused on using it for safeguards. So again, in that area of computer vision, in the area of materials accountancy, so it has a lot of applicability in that area as well. In the security domain, we've watched some. There are international applications that we're aware of. There's actually one where there is a use case that's being brought to an international regulator to use computer vision for site monitoring. And so that'll be one of the ones we're watching to see how that's evaluated. Not in the US. We don't have a use case for that right now. But so AI use cases for cybersecurity, physical security, safeguards, they're all there. They're all, what we've been tracking is much more in the research phase, but they all have some use case that could be very useful for the industry, as the industry is continuing to look for ways they can optimize, cut costs, improve efficiency, and in those particular areas.
Andy, what about in the UK?
So in the UK, it's very similar to what Matt was just saying, actually. So there's a lot of research going on at the moment, and we are trying to keep an eye on what that research is saying and where that might go. Of course, what we're looking for is real products that will make a difference to safety, security, and operations. I'll give you an example of something that has been done within the UK already, and that is the deployment of a robot quadruped in one of our waste facilities. Basically, this has replaced humans in a number of radiation facilities. It avoids humans having to go in a radiation suit to take readings and to look at the state of the facility. And there's been a huge benefit, obviously, not only for the operators in terms of reduced dose, but also in terms of the fatigue for operators, also reduced health physics monitoring, the amount of authorizations required to get entry into those facilities. And it's really turbocharged the facility's ability to actually get data off the site, out of those facilities, which otherwise it would be hard to do. And in fact, this robot has even gone into facilities which you would not be able to send a person into either. So actually, it's allowed this particular operator to do something that no other means can be used to achieve that. So very, very beneficial. I've got another application actually, which is this sorting and segregating of waste, which is being considered, which again is replacing an activity which is very manual at the present time, using manipulators, and it's quite slow and quite difficult. And using robots and machine vision, there's this opportunity to really accelerate the sorting and segregation of waste, improving the disposal of that waste to the right route, which is actually has a huge benefit in terms of costs to the industry. So I'll stop there, but there's many applications that are being considered in the UK.
The waste one's a great one. And actually, Kevin, now that Canada has selected its host site, AI might become more of a thing, actually, for the Deep Geological Repository. But over to you in terms of the Canadian experience related to security, safeguards, and other efficiencies.
So around security and safeguards, Andy talked about something in terms of, turbocharging the ability in certain areas surrounding safeguards and security. But I also want to touch on something that happened 2 weeks ago. Sarah in the Vienna Center for Non-Proliferation and Disarmament hosted a two-day workshop on cybersecurity, AI, and supply chain. And one of the things, and everything that Matt and Andy said is absolutely true. There's all kinds of benefits that will be incurred both by industry and regulators when it comes to safeguards and security. But one thing that did come out of that session was that as much as it ups the regulators' game, it also ups the bad actors. And there was talk at that session about how AI allows, let's say, bad actors who didn't have a level of technical sophistication. It enables them to a higher level. So it means there's potentially more bad actors out there. So I just like to put that out there as something to be, as much as we look at the really good things that can happen, that we also need to protect against those other things that can really derail stuff.
And a very good point. And Sarah, I know you've got another question, so I'll turn it over to you.
Thanks, Cindy. And Kevin, you've given me exactly the transition that I needed to get to my next question, because I've worked now for most of my career, not all of it, but most of it in nuclear security, which means I have a tendency to think about, okay, that's all really great. That sounds amazing. What could go wrong? Which inspired the workshop that Kevin was just talking about. And it's going to inspire my last question to all of you. And rather than starting with Kevin, who led us into this, I'm going to start with Andrew, actually, since you haven't had a chance to be first, and ask you this question. Let's look at that other side. Where do you see security risks, but also safety risks when AI is integrated into operations, into all of these 30 use cases, into admin and everything else? So will these things need to be mitigated with regulations? Can they be? Will the existing regulations pretty much do it? Or is there going to be some rethinking needed?
There's real challenges, aren't there? I think it's all there, really. You've got highly complex systems. You've got vulnerabilities, potentially. You've got bad actors who might view this as being a really good target. So essentially, I think it is hugely challenging and a hugely challenging area. So not only that, but it's a hugely challenging area in terms of actually having confidence that the AI will do what you need it to do. So if you're deploying it in a safety application or a security application, is the AI doing what you intended it to do? For me, as a regulator, I think that poses a number of challenges, which is, okay, how can you regulate against something which is almost inherently vulnerable to those kind of safety and security challenges? in the UK, we have an approach which is quite different from the rest of the world, which is we expect our operators to show that the risks have been reduced so far as is reasonably practicable, which basically shows that actually if you've got significant benefits, then you can say, well, okay, yeah, there is a risk that this could go wrong, but actually we can manage those risks. We can get the benefit and we can maybe mitigate the consequences, for example. So we know, for example, that testing is not a really good way of showing the system doesn't contain faults or problems that you haven't found. And in fact, there are multiple ways that you can deploy AI. And we're actually just kicking some research off to actually start to enumerate those and to put those into a public report, which will start to describe how you can use AI in applications where you wouldn't actually consider using it in normal circumstances. We believe that there are numerous such ways that you can actually protect yourself from the worst consequences and manage things such as security and also the safety aspects of failure of AI.
Andrew, thank you. That was actually really a very thorough response, a good setup for the next person who's going to answer this. And so I think I'll turn this time back to Kevin and ask, do you have anything to add to what Andrew had said? Any extra subtleties, perhaps?
I actually have a lot to add, but I'll try to make it succinct. So the CNSC, we regulate nuclear activities. So we would regulate an activity that utilized AI. So it's a different mindset, different way of looking at it. You're not actually regulating AI per se. We reviewed our regulations and our regulatory framework 3 years ago. Is it fit for AI? Is it okay for AI? We thought it was. We got a third party to do a report going over our regulatory framework, published 2 years ago. It's available on the CNSC website, basically showing that yes, more or less, the CNSC's regulatory framework is ready for AI. Having said that, there's aspects of it that I think might merit further attention down the road. One that I'm very big on, and I'm personally a huge proponent of, is human in the loop. There's a lot of, I think, talk about implementing AI and the AI is the solution. And quite often individuals forget about the human in the loop. And I think you have to keep that central. Mm-hmm. And if you don't, that is, in my personal opinion, where you're going to end up with problems. The other area that I would say we need better international standards on is around, by standard setting bodies, so that regulators can utilize those standards, is around cybersecurity itself. It's an area where I think, the session that you hosted 2 weeks ago, Sarah, there was again consensus that there isn't really standards you can point to. Yes, there are software standards. The question is, are they applicable? So I would say that, currently, yes, we think we're okay, but we don't know what new things are going to come down the road. What we need to do, and I think what all three regulators kind of proved with the AI principle paper, is that AI is just a new innovation that's come along. We've had that in the past. We've been able to regulate sufficiently and safely when new things come along. There's going to be something else new that's going to supersede AI down the road. So you want to make sure that you set up your regulatory regime such that you protect against, let's say, you make it flexible enough that when that something new comes, you don't have to put a stop and say, no, can't do it. You have to have a risk-informed graded approach. And if you follow that, then you should be okay. But I'll go back to and just say human factors, cybersecurity definitely merit more attention.
Yeah, thank you, Kevin. I really liked particularly your point at the end. Look, we're talking here about AI. AI is a huge technological innovation. It's changing fast. It's a big deal. Who knows what it's going to be tomorrow? AI is probably not the end. A new version of AI, something else, who knows? And so while we're talking now about what we need to deal with right now, more is on the way. And with that, I'm going to turn to Matt and see if he has some insights on this before we go to questions from the audience.
So the NRC's sort of in a change mode right now. We just issued a new mission statement, and safety and security are our guiding principles and our focus for everything. And so with that in mind, we kind of already knew 3 years ago that this might be of concern when it comes to AI. Mm-hmm. So that's why we issued our AI strategic plan, New Reg 2261. And in that brought about a lot of actions. And one of those was doing a regulatory gap analysis specific to how our regulations were influenced by the new uses of AI. So just like Kevin said that the CNSC did, they did a sort of a gap analysis to look at their regulations. We did ours. We just presented ours in November to our advisory committee on reactor safeguards. And the overall conclusion was that our regulations from the actual Code of Federal Regulations are fairly flexible enough to adapt to artificial intelligence. It's where you get into the nitty-gritty of the actually how do you meet the regulations that it gets a little more nuanced. And so how do you verify the explainability, the interpretability, all those illities of AI to meet the regulation and satisfy your application area, that it becomes a question. And so to that end, we have a lot of regulatory guidance. And so in our project, we looked at how do our reg guides address AI? And none of them, of course, explicitly use the word artificial intelligence or machine learning anywhere. And so we are undertaking a project right now to sort of go through and figure out, are there targeted areas we need to address? What are the requirements or things that need to be shown to prove AI is safe and secure enough? Or do we need to have one reg guide to point everyone to the technical reviewers in the NRC and license applicants and those in our oversight function can use to review AI. So that's kind of where we're at right now. But all of that said, we sort of pointed these things out in our trilateral paper that right now, Andy or Kevin mentioned standards. And so there's not a huge amount of consensus standards that we would endorse in those regulatory guides right now specific to AI and nuclear. So developing those is important. We pointed that out in the paper. Considering human organizational factors and using the safety and engineering principles that we currently have today that we use for nuclear power plants and to license those are a perfect starting point for anyone who is considering using an AI application in the near term for a regulated function.
Wonderful, thank you. So I'll take, there are some great questions actually already teed up. And let's talk about a little bit more about the data. Where's the data coming from? How concerned are we about the data? How do we know the data is correct? And I'm also going to include Gretchen in this. And the question specifically is looking at predictive analytics for safety and security measures. Do you think data availability will be a challenge, since these models usually require vast amounts of data? I'll open it up to the floor.
This is Gretchen. I'll jump in for just a second, because I think what DeepSeek and other things have shown is that you can create smaller versions of those large language models so that you do not always need as much data. Again, think about, especially in the industry that you're in, it's not as if every single person carries a nuclear power plant in their pocket, right? So there's a fewer set of those. So there's probably some data that would never have any impact or any influence on what you're doing. So you would not bother to pull that kind of data. But also, I think the other thing that's really important is ensure that you bring the technology to the data, because I think part of the challenge sometimes is that you're pulling all of this data and you're bringing it to some central database or whatever it might be. And a lot of that data probably doesn't matter. So you could just sort of drop it at the edge, so to speak. But if you can bring the algorithm and you can create smaller algorithms, containerize them with the microservices, not all of the software that you need right at the edge, and then leverage the technology, i.e. the hardware that's there, so that you can have trusted attestation that's built in. So Intel builds those kinds of things in the hardware. So the software can attest, is this a known system? Is this known data? Is this something that falls within the right parameters? If it does, terrific. If it doesn't, react to it in the way that you need to. I think that again, there's a lot of software there, but you need to really connect it to safeguards and not only attestation, but even the ability to create a secure enclave from a hardware perspective. So if you are finding bad known actors, to the point I think it was Andrew and Matt were both making, if there are people that are trying to intrude into the system or trying to add bad data to then askew something in a way that it isn't right. Again, attest that is absolutely a bad actor. Put that person into an enclave so they don't perturbate the environment at all. And I think there are those kinds of hardware, software mitigations, and to all three of the regulators' perspectives, industry needs to be there talking with you, because you probably don't know that we have a lot of that stuff. We're engineers. We just believe if we build it, someone will come. So having those kind of conversations, you might realize, most of the stuff is Siemens and GE and others, and it already does have this stuff inside of it. So, you can leverage AI, honestly, to be a snifter throughout your entire environment and find out what's there. And then from that baseline, give yourself the right situational awareness and know, am I getting good data? Are there other things that I maybe need to add into the environment to collect the data that I need?
And actually, that's a really good point. AI like a sniffer dog, which actually, and I'll see if I can combine a few questions here. There's some questions related to, what does it look like at the international level? Is the IAEA looking at safeguards? And so I'd be curious from our regulators what kind of conversations you're having with the IAEA. And I should also note to the audience, last week, the IAEA held its emerging tech workshop, and it focused on AI and their incubators. And the Department of Safeguards has certainly been looking at AI actually for a lot more number of years than we might have assumed. But I would be curious from our regulators, what does that look like at the international level? And then if I could add a little point, and I only have 4 minutes left, but what about harmonization? Are we there? Can we get there on AI or not in terms of regulation? That's a question from the audience. Who wants to take it?
I'll jump in and say all three parties have been quite involved with the IAEA. The IAEA a couple of years ago had their AI for Atoms kickoff, and that splintered off into a lot of their work streams. So each area, waste, safeguards, nuclear power, nuclear medicine, so all the nuclear things have some AI component. And I know Andy and myself are involved in a safety series. Kevin and I are involved in one for nuclear power. So I guess the very short answer is IAEA is definitely involved in AI for nuclear. Where they go in harmonizing anything is, it's difficult to get a global consensus from all the member countries on AI safety and security and whatnot. So it's a tall order for them, but at this point, they're putting together what would be considered sort of like a best practices, I would guess, of, how can they best support the member states in considering AI in nuclear application.
I'll jump in for a minute. Just to say that international harmonization, even amongst close neighbors and friends, is sometimes difficult. And Matt is absolutely right. The IEA is definitely moving in the right direction. I'd like to put a plug in actually for the Innovation to Support Operating Plants, which is a subgroup within the IEA under their nuclear engineering group. And that group has done a lot to get sort of at least a consensus approach to AI internationally. So Matt, you're absolutely right in pointing to that, because that's really great work. And if anyone doesn't know about it, you should look it up. It's a great part you should be a part of if you want. It's a very open network. So I think that's definitely a step in the right direction. Whether or not we get to global harmonization, well, that'll take a long time, I think.
So can I just say that this is a very challenging area, and as far as we were concerned. One of the things that we believe we've achieved with the trilateral paper that we published is actually really strong agreement about what's important in AI, what's important to look at, and it covers all those areas: engineering, safety, good engineering, safety principles, human factors, actually being able to make the demonstration, and essentially, we have that strong agreement between the regulators, and we hope that will mean that applications can be transferable between the different countries.
Thank you. Well, on that, we've got 1 minute left. So what I'll do is just thank you all for a very good conversation. I know it's quick, and I'm hoping we can have more. This is the first of many, obviously, in terms of AI and nuclear, but also hopefully among ourselves. And I think what I'm hearing more, which is actually a really nice thing, because particularly in the nuclear space, it's usually doom and gloom when we introduce new things or the fear factor. And here we are, there's been a lot of conversation about AI for good and how, of course, it's already being used for good to help create greater efficiencies within the sector. So I know our 3 regulators have a lot of work ahead of them, and I'm sure we're going to see updates to that paper over time. And I also just wanted to say thank you to Gretchen. You also have a very busy job, and look forward to hearing a update maybe in a few months' time as to where we are, since things are moving so fastly. And of course, lastly but not least, Sarah, thank you so much for being a co-host. You rock. As always, Stimson and VCDNP work very well together, and I look forward to taking the series further forward. Thank you all, and to our audience as well.
Thank you, everybody. Thank you, Cindy. Thank you, regulators. Thank you, Gretchen. Audience. Have a lovely evening.